So one summary statistic you need for sure is the count of the values. And we usually give that the letter N. And on a spreadsheet, that's just the command count and then point to wherever the data lives. Next popular one is average. We usually give that the letter X with a bar over the top. Average is also called the arithmetic mean. And it is the sum of all of the values divided by how many, which would be the count. And on a spreadsheet, it is just average. Parentheses, and then point it to your data. Now, some mathematical symbols for this. Maybe you've seen this if you're an Excel user. That symbol right there is the capital Greek sigma. It means sum, add stuff up. So you might see that capital Greek sigma looks kind of like an E with an X next to it, divided by N. And again, all that means is sum the variable values. X, right, in math is a typical variable. So it could be the ages. X is someone's age. So this right here says add up all the ages, divide by how many ages there are. M, the median. On a spreadsheet, it is just median. Parentheses, point the spreadsheet to your data. And again, we'll try these in a minute, kind of small data set by hand, and then bigger data sets on the spreadsheet. If you have more than 10 or 20 numbers, it just makes sense to use a spreadsheet, not a calculator. The median is the middle number of the sorted data. So the data has to go largest to smallest or smallest to largest. It doesn't matter. And then you want to pick the middle number. Now, there's a slight problem with the idea of median because for some groups of numbers, there isn't a middle number. Right? Think about it. If there are 9 values, the 5th one is going to be in the middle. If there are 10 values, there is no middle number. The 5th and the 6th numbers would be the middle. So as far as deciding what the median should be, you have to find the position of the median in the list. Position. And the position of the median is going to come from taking the sample size, that would be N, and dividing by 2. And then one or two things going to happen. Either this is going to be a decimal value, like if the sample size was 9, 9 divided by 2 is 4.5. So that means we grab the 5th number. So if it's a decimal value, you're going to round up to the next position. If it's not a decimal, then it's going to be a whole number. So that would be like 10. 10 divided by 2 is 5, but 5 isn't the middle number. The middle is in between the 5th and the 6th number. So in this case, then we average this position with the next. And I'm pointing this out because we're going to try and do it with a small set of numbers, but if it's a big set of numbers, we just let the computer do it for us. So again, examples of this. If n equals 9, so we have 9 numbers in our data set, n divided by 2 is 4.5, which means the 5th number is the median. If you're not sure about that, just think 1, 2, 3, 4, 5, 6, 7, 8, and 9. Selecting the 5th number, there are 4 numbers on each side, right? 5 is definitely in the middle there. If n equals 10, 10 divided by 2 is exactly 5. But think about the numbers again, 1 through 10 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we focus on the 5th number here, there's 4 numbers to the left of it, but 5 numbers to the right. That's not the middle. So my rule there is we average whatever number is in that position with the next one. We average these 2 numbers, whatever they are. They may be 5 and 6, but it could be something else. Depends on the number list. So average these. Spreadsheet makes that decision for us when we say, hey, find the median. The mean and the median, the average and the median, they're considered measures of center. And just a side note about why we have 2 different ways to find the middle, because they're not necessarily going to agree with each other. There's a couple homes for sale on my block. So home prices and housing prices have gone up a lot over the last 5 years. Houses that used to be, say, $150,000 a few years ago are now $200,000. So the housing prices in my block look like this. 150, that's thousands. 200,000. There's another 200,000. There's another 200,000. Oops. I'm gonna put all those there. So I'm gonna do home prices in thousands. There's another 200,000. And then there's a $600,000 house. If we look at the median here, there's 1, 2, 3, 4, 5, 6 numbers. So the median would be right in between these 2 that are 200. So the rule for the median in this case would be take the 200 to the left of the middle plus the 200 to the right, divide by 2, well, that's still 200. The mean for this would be to add them all up. 100, 150 plus, let's see, 1, 2, 3, 4 200s. I'm just going to write 4 times 200. It's easier. Plus 600 divided by, how many are there? 6 of them. All right, what do we get when we do that? That gives us 800 plus 600 is 1,400, 1,550. All right. So double check that in the calculator in a minute. Divide that by 6. And again, I love using calculators. I'm doing this by hand. I don't know why, because I just needed some exercise today, apparently. Let's see, I don't feel like dividing that by 6 in my head. Do I? Oh, sure, why not? Let's try, see if I get lucky. Let's see, 6 goes into 15 twice with 3 left over. 6 goes into 35 5 times. With 5 left over, and 6 goes into 58 times with 2 left over. So 2 6 is what point? Oh, that's 1/3, 0.333. So I think it's going to be like 258.33-ish. Let's check on a calculator. This is getting painful. Bring up Desmos, although a spreadsheet is a calculator. Kind of weird that I'm bringing up a regular calculator. Oops, that's not the right Desmos, but that's okay. So let's see, I have a fraction with 150 plus 4 200s plus the 600, divide that by 6, 258.333. Holy crap, I got it right. A good day for me. All right, so according to them, so somebody says, hey, what's the average house price in your neighborhood? Would I tell, was it safer to tell them it's almost 260,000? Or is it more reasonable to say it's 200,000? Right? Isn't that one house at 600,000 kind of unusual compared to the rest of the houses in the neighborhood? If you walk into my neighborhood, you're going to see there's all these little houses and there's this one giant house, right? It's out of place in the neighborhood. So in this case, because that 600 is so far out compared to the rest of them, it's kind of skewing the mean as a measure of centriview. Is 258.33 the average? Yeah, it is. But in terms of like describing what's a more meaningful answer in this case for the middle of these numbers, I would say 200 is more meaningful because the 600 seems unusually large in terms of the prices compared to the rest of the houses. Right. So is there a best measure of center? The answer is no, but sometimes one measure is better than the other. And so in this case, I would say median would be a better measure for the average house price here instead of the mean as the average. Now, here's another thing to point out. Let's suppose that they did some major upgrades to that house and it's now worth $1 million. I'm sorry, $100,000. That would be 100,000. What's the median? It's still 200, right? 200s are in the middle. So the median doesn't care what the maximum is. It just says, hey, I'm the number in the middle. Is the average going to change though? Yeah, the average is going to change because this total just went up by $400. So that's going to be what, 1950 over 6. Let's check that out. So change that 6 to, let's see, I did something wrong. Oh, I meant that to be bigger than what I wrote it. Sorry. Typo. I want it to be 1,000,000, which is 400,000 higher. Okay, that 1950 is still okay. Just made a mistake up there. I'm going to change that 600 to 1,000, and now I get 325,000 is the average house price. Further skewing what the mean is telling us. So what's the point of this story right here? The point is, so this would be 325,000. K is a summary for abbreviation for 1,000. The mean is affected by extreme values in the data set. The median is not. That's the moral here. Doesn't make the mean bad. It's still a good measure, but it is affected by extreme values in the data set. Now here I use the example of an extremely high number, but it could be extremely low numbers that are way lower than everybody else that are messing things up for the mean and dragging it away from the median. If the mean and the median are close, that means your data is relatively symmetric. There isn't too much on the high end that's way high, too much on the low end that's way low. So another side note, the mean and median will be closer together if the data is symmetric. And we'll see some examples of symmetry later. So in this case, symmetric would be the middle according to the median is 200. If I go back to the 600, that was 400 higher. We would want some numbers that are 400 lower than the median to make it symmetric. Right? We'd have balance on the left and the right. All right. let us look at a spreadsheet. Let's go back here and let's pick on age. So there's that graph we are not going to make. Delete. And I'm just going to move this histogram out of the way. Okay, so summary statistics on a spreadsheet. And if you are with me now, this spreadsheet that I'm playing with is also located on the describing data resource page. And if you're watching this on video later, it will be linked in the description of the video. So again, summary statistics that you got to have the count. How many are there? Blow this up a little bit. And count is simply, again, when we do a formula on a spreadsheet, we have to start with equals. It's just count. Now notice here it says count is the number of numeric values in the data set. If you wanted to count words, like when we had male, female, or eye colors, you would have to use count A to count all of those. Count A counts words. Count on its own just counts numbers. So if I pointed count at the list of genders, it would say 0 because there's no numbers in there. So count is for numeric quantitative data. And all I do, it's going to ignore words like the word age at the top. So in most cases, it's safe to just select the whole column and count them. 606, holy shit. Okay, so in this case, it might not be safe. How many numbers am I supposed to have? I think it was 306, 307 when we were looking at this earlier. All right, so something weird's going on there. What's the safe thing to do if you're not sure? Go to the top of the numbers and then Control-Shift down arrow will take you to the first open cell. And so I'm just going to keep doing that till I'm sure I'm at the bottom. So Control-Shift Enter, I'm hitting it over. Ooh, I accidentally copied the numbers a second time in there. How did I do that? Crazy. All right, I'll fix that in a second. All right, it says there are, and I don't want to fill it down. It says there are 303 numbers. It's ignoring the blanks where people decided not to give me their age. All right, let me fix this before we move on. Oops. All right, those guys gotta go. Somehow I must have been messing around. I've got 2 copies of the same data in the same column. How do you get back to the top? Just Control Enter will take you to the top. All right, other important one, average, also known as the mean. And it is simply just average. And now it's safe to highlight that column. So I have an average age of 26-ish. How many decimal places should I show? The rounding rule in statistics is 1 more decimal place than what the data shows. So if my data is all whole numbers, then I should round the average to the nearest 10th. So I'm just going to decrease decimals there. So we would say the average is 26.0. Median. Now, the median is the middle number when they're in order. Are my numbers in order? The answer is no, but the spreadsheet will do that off to the side. It'll order them and then find the middle number. So I don't have to worry about it. So equals median, and just highlight if the column if it's safe, otherwise highlight the from the first to the last number. All right, so this has a median of 22. Okay, so that's interesting. The average is higher than the median. What that means is there's a few ages that are way higher than the majority of students in this case. That's pulling the mean and the median apart. It's not symmetric. So the data set has what we call a skew to it. And let's see if we can see that in the graph. Let's zoom out here. And oops, I messed up my graph. It's okay, we'll start over. What kind of graph should I make? I should make a histogram. So I'm going to insert chart. And it picked the pie chart. That's a nonsense pie chart. Would a bar chart be appropriate here? No, that's bad too. I want a histogram. Google picked 2.65 as the histogram width. That was an interesting choice. So I'm going to customize. I like the one with 5. I thought that was cute. That's nice. Right. So symmetric would mean you see some big stacks and there's just as many small stacks to the right as there are to the left. We can see here there are no small stacks to the right, just a bunch of small to the left, sorry, just a bunch of small ones to the right. So this data is not symmetric. It's what we call skewed, and the skew is to the tail. So I would say this is skewed to the right. Because there's a few people that were quite larger than the majority. What are the majority of my students? Well, the 2 tallest stacks, I would call the majority. Could be 3 tallest stacks, depends on your data. Somebody might say, the majority of students are between 15 and 30. Okay. So again, usually for majority, it's greater than 50%, wherever that cutoff is on the data set. So let's see. How many are in this column? Click off of it. Let's see. There we go. If you click on the chart after you're done editing it and then you point to a column, I'll show you how many. So there's 82 in that column. There's 100 there. So that's what, 180-ish, which is slightly over half of 300-ish. So I would say, yeah, majority of students are between 15 and 20 years old. I'll take my math classes. All right, let's see. Count, average, median. You can find the mode of a quantitative variable, but it's often not that meaningful. So I could ask for a mode, but generally I find it's not useful for quantitative data. It is for categorical. So there's a function called mode, and it'll look through your data and say which number or numbers occur most frequently. And this says 19 occurred more than any other number. All right, so those are measures of center. With the measures of center, we need the count because that is part of finding the average. Although you can find these by hand, my recommendation is for any reasonably sized data set, please use a computer because humans make too many mistakes.